Hi folks, we're going to be finding the highest common factor and the least common multiple from prime factorisation, which means when the numbers are given to us in the powers of their prime factors. So here's an example to begin with. We're given two numbers, 210, written as 2 times 3 times 5 times 7. So that is the prime factorisation of 210, which means it's written as the multiplication of its prime factors. If you can't remember how to do that, you might need to nip back and look at the video on factor trees. 180 is 2 squared times 3 squared times 5. And so we're given these two numbers and we need to find the highest common factor and lowest common multiple. We play a little game of what we call winners and losers. So we compare in each number the corresponding prime factor. What do I mean by that? Well, in 210 and 180, a 2 appears as part of the prime factorisation. For 210, it's a single 2. For 180, it's 2 squared. Now, when we compare those two, which of them wins, as in which is the biggest, 2 squared or 2? That should be fairly obvious to us, I hope, that 2 squared is the winner and 2 is the loser in that little matchup. Then we do exactly the same with the next prime factor, which is 3, and we're comparing 3 in 210 with 3 squared in 180, and the winner of that matchup would be 3 squared and the loser would be 3. We move on to our next prime factor, which is 5. Now we can see we've got a 5 both in 210 and 180, so we call that a draw. So when it's a draw, as it were, both of them are winners and losers. So we put a 5 in the winners list and a 5 in the losers list. And then finally, our very last prime factor is 7. Now in 210, 7 doesn't have anything to compete against with 180, so 7 is automatically a winner. Now when we have our list of winners and losers, the lowest common multiple is the winners list multiplied together. So in our winners list, we have 2 squared, 3 squared, 5 and 7. We simply multiply them together and that gives us our lowest common multiple. In our losers list, 2, 3 and 5, well, we multiply those together and that gives us our highest common factor. So that little game of winners and losers helps find the lowest common multiple and highest common factor. Here's a second example. Once again, 60 is given to us as the product, the multiplication of its prime factors, and 2,200 similarly given to us as a multiplication of its prime factors. So remember, we're comparing the same prime factor in both numbers, so we're going to start with 2 and we're comparing 2 cubed with 2 squared. I hope you can see that 2 cubed would be the winner and 2 squared would be the loser. Now in our next prime factor, that's 3, no, we don't compare 3 with 5 squared just because they're written under each other. Okay, our next prime factor is a 3 and we've got the 3 in the 60, but we don't have a 3 in the 2,200. So 3 is automatically a winner. Our next prime factor that we compare are the 5s. So we're comparing 5 squared against 5. 5 squared is the winner and 5 is the loser. And finally, we're comparing 11, but we don't have an 11 in the 60 factorisation, so 11 is automatically the winner. We therefore multiply our winners row, and that gives us the lowest common multiple. In this case, it's actually 6,600. And in our losers row, it's 2 squared times by 5, and that's 20, and that would be the highest common factor. So that's how we find the lowest common multiple and the highest common factor, playing a little game of winners and losers.